Okay, let's do this question. This one yesterday, but it wasn't the best way to solve it. So if you look at that one, I solved it using 3 passes. I could have done it in 2 easily, but you can actually do it in 1. So this is a very simple, the first part is simple because this is very similar to the question to find the max subarray sum, which is just using dp. You just want to calculate dpi, so this is the sub-problem. Oh, I should probably explain the question first. So you're given an array of nums, and you want to find the max subarray, basically. But the catch is the subarray is circular, so you also have to handle that case as well. What if the subarray kind of goes past the end of the array and peeks out the front? So the sub-problem of just figuring out, if you're not caring about the circular part, then dpi, if that's is equal to the max subarray sum of subarrays ending at I, then if you just calculate the max out of all of these, that would be the answer for the case where this is not circular. So the transition would be something like dp of I is equal to the max of, so either I want to add the current number, so nums I, to the previous one, or I just want to take nums I, so whichever one's biggest. So either start a new subarray from here, or continue on from the previous one. So that's the transition. And this handles the first case, so you notice that there's only 2 cases, and a good good example is this. For the first case, we're assuming that within our view of this circular subarray, the part that we take, the subarray that we take, has to be contiguous and not split up like in the circular case. So we either take something that looks somewhat like this, so our subarray has to be contiguous like this. Turns out the best answer would be the addition of all these, which would be 8. Is it 8? Yes, that's 10 minus 2, so that's 8. The second case is if we take this and we have a subarray that starts at the start and another subarray that ends at the end, but they don't overlap. So this is the other case. So it could be any combination. This could be more than here. This could be just 1 at the end or something like this. So my previous solution was to figure out the prefix sums, and as I go along the prefix sum, I take the max prefix sum I find and do it in the reverse direction, and then for each position I consider all possible, and for each position I consider the max subarray before the current position and after the current position, and then sum those up and then take the max out of all of those. So that was my previous solution, which worked, but and it was still linear time, but there's a way you can do it in 1 pass, which is a lot cleaner, and that is if we were to instead reuse the same algorithm we have here, but instead of trying to find the max, we try to find the min. So that's like trying to find a min in between here. And then what we could do is take the max, the total, minus that min, and that will give us the max subarray that looks like this. So that's another way you could do it, and that's neater because you could do it in 1 pass. as we'll see. So there are a bunch of variables we need to take care of. So we need a total as well for that min part, and you also need like a max dp, a min dp, a subarray min, subarray max, and subarray min. We can initialize everything to be the first element of nums, because that would be a good base case actually for what the max subarray is for ending at position 0, and it would also be the answer if in the case where there's only one element in the array. So max dp is equal to min dp, max, and also s min, which is equal to nums 0. Since we've handled the base case, then we only need to consider I up to starting at 1 and I less than nums.size plus I. And then we just use the transition here that we have, which would be max dp is equal to max of the current, the previous max dp plus the nums I, or just start a new subarray starting from this position. And you also want to accumulate what the max is in S max of what S max currently is in max dp. That would be the answer for the first case, S max by the end. So this is calculating the max subarray sum. And here we also want to probably calculate what the total is. And here we want to calculate the min subarray sum. And it will be very similar. It'll be min dp is equal to min of min dp plus nums I and nums I. So we start a new one here. And s min is equal to the min of s min and min dp. And at the end, we could just return the max of either the total minus s min or s max, like we talked about. Although there is a problem, in the case where all these are negative, then the min subarray that we're trying to find is actually the whole thing. So we'll be doing the total, which would be 12 minus 12, and subtract minus 12 from that, which will give you 0. But the answer is actually minus 2, and the max of 0 and minus 2 is 0, which is wrong because the answer is minus 2. So we need to make sure that the min subarray has at least one, actually the resulting subarray has at least one element in it. So if the min subarray is everything, then that doesn't work. So that's another way of saying the min subarray has to have at least one element missing from it. If there's an element missing from the min subarray, then it won't equal to the total. In the case where that missing element is not 0, but if it's equal to 0, that doesn't really matter much because this case only applies to negative numbers, this edge case, so that doesn't really matter. So we just need to check if this is equal to 0. So we could say the alternate answer is total minus s min. But if the alternate is equal to 0, then set alternate into int min and use alt here instead. So that would mean that in this case we are not considering alt at all. Alright, so that works for the case where it's all negative. Let's try with this. Seems to work. Okay, give that a go. Awesome. That's a good score.